Okay, we are 5 minutes into the class, so we're going to get started now. So the first thing I'm going to do is to go over the exam. Exam 1, I have graded everything already. So I want to kind of go over the questions, the correct answers, and also kind of go over, how I grade it. So that when you read your grade, you kind of know how it is graded. If I grade yours incorrectly, you can send me an email and let me know that okay, I think I got this one here. You might have overlooked it, and can you just take a second look at it? So that's perfectly okay. So I have photocopies of every single test, so you can just tell me which questions and what you think is not right about the grading, and I can take a look. Okay. All right. So the first thing we need to do in that case is to first take a look at the exam again. So this way we can look at the answers, and then you guys can kind of have a better understanding of how everything is scored in that test. The exams is here. It is scored by the questions, so we have X1Q1 to X1Q3 as quote-unquote homework assignments. But I'm only borrowing the homework assignment mechanism so that I can use a rubric-based method of grading your answers. Okay, so they're not actually homework assignments. They're really corresponding to your question 1, 2, and 3 for the from the exam. Okay, are there any questions I can answer over there? Nope. Okay. All right. And this file is a zip file. It contains, or tar.gz file. It contains all the questions. May not be all the variants, but I think it contains at least most of the variants of that question. So we'll go ahead and take a look at those questions. And they should be downloaded here, xzvfx1.tar.gz. All right. So let's take a look at question 1 first. There are 2 variants of question number 1. So I'm only going to use one to kind of talk about the correct answer. All right. So this is the question on Johnny. And you are supposed to answer a few questions and also to tell me, describing in general what the instruction does. Okay, so I'm going to talk about how what type of answers I'm expecting and how you can get to those answers. The first thing you need to do is to look at the picture, the snapshot of Johnny, and then go from there. In other words, you look at this picture and you go basically, okay, where do we go from here at this point? Now, unfortunately, I was too cheap, so I was only using a black and white printer to print your questions. So you cannot actually see the yellow line here for the most part. That's why in the class I kind of emphasize, okay, this is the fetch instruction. We start with the fetch cycle, which is the detail over in the smaller box here. Okay, that's the fetch cycle. And one of the variants of the test, that's after I kind of made some changes already to the screen. So that particular screen was off, it was scrolled up, and that's why I wrote it on the whiteboard. So there was the fetch cycle specification was on the whiteboard as well in the exam. Okay. All right, so let's start with the fetch cycle. And I'm going to magnify this screen a little bit just so that we can see a little bit better what we are doing here. All right, so as far as the fetch cycle is concerned, the first instruction or the first microcode is PC to AB. So you have to look at the program counter, which is PC, and it latches 001 to the address bus. So the address bus is going to end up with 001. Okay, so I'm just going to scroll to the right item here. So 001 will go up to the address bus, and then the next instruction or the next microcode is RAM to DB, which means the content of 001 in memory is going to be present on the data bus. The third microcode is DB to INS, in other words, data bus to instruction register. So whatever the content is in location 001, which is 11003, will now appear in the instruction register. And then the last instruction is instruction to MC. It will look up the table inside the microcode table and figure out, okay, what am I supposed to execute at this point? That will make use of the high portion of the instruction register, or 11 in this case, to look up the microcode for that particular instruction. the instruction for that one is already listed here. So from here, we just look up these instructions and find out what it does. The first instruction is equal to 0, PC++. What that means is if and only if the accumulator is 0, increment the program counter. Okay? Now how do we know that? I wrote it on the whiteboard. I wrote the instruction, I wrote the meaning of all the microcode on the whiteboard during the exam. So that means you don't even need to look up anything. It's on the whiteboard. Okay? So if and only if the accumulator is 0, increment the program counter. What is the program counter at this point? 0, 0, 1. Okay? You can use 1, but that's fine with me. Okay. And depending on how about the accumulator, what is the value of the accumulator at that time? It's non-zero. Okay. All I need to know is it is non-zero. So because it is non-zero, am I going to increment the program counter? No. So the program counter stays put. It is not incremented, which means the program counter is still pointing to the very same instruction that I'm executing at this point. So, and then I go through PC to AD, RAM to DB, and then DB to INS again, which are the same 3 instructions in the fetch cycle. Is that okay? But what is following that, or in location 114, is different. In 114, I put INS to PC, which doesn't seem to be necessary. But it is necessary if I did increment the program counter, because in that case, the program counter would have changed to whatever the low portion is for the next word. And then I reset MC to 0, the microcode counter is reset to 0. Okay, so from this, let's go ahead and take a look at the correct answers to these questions. Does the instruction read any memory content? The answer is yes. Okay, it reads the content, and which location does it read from? 001 is the correct answer. Okay, so we have 001 here. Does the instruction overwrite any memory content? Now this one is, I was hoping that most people would get this one right, because in order to write to memory content, what type of microcode instruction do you need? DB to RAM. DB to RAM, something to RAM, right? Because in order to write to RAM, and is that specified anywhere in the microcode of TAC or the fetch instruction cycle? Nope. So that's why the answer is no in this case. I'm not overwriting any memory content. So this part is no. And since it's no, it does not apply. The next question does not apply because it says, if so, which memory location does it overwrite? And then over here, it asks, does this instruction alter the accumulator, the TAC instruction? Nope. The only thing it does to the accumulator is to check whether it is 0 or not, but it doesn't do anything to change the value of the accumulator. So in this case, the instruction does not change the content of the accumulator, which means the next question here is irrelevant. Most people just kind of leave it blank, which is fine. You can also use NA, not applicable. Okay, that's also okay. And then the most tricky one, that I think is this one here. What is the address of the next instruction to execute? Now, I did not make this instruction tricky enough, so most people actually get this one right. Because when you look up the picture over here, with this instruction loaded into the instruction register, and with the instruction register loading the program counter, 003 turns out to be the next instruction. Okay? So if I go back here, I'm going to answer my own question here. So you have to answer this one with 003. All right? So that would give you some of the point values associated with this question. But the most important part, and also the part that is most difficult for me to grade, is the description of the instruction itself. So what I'm looking for is the following description. Okay? What I'm looking for is, one, it depends on the value of the accumulator. Okay? Just the mentioning of it depends on the accumulator will give you at least some partial credit. Yes?
Is it infinite loop?
It is not an infinite loop. The instruction itself is not an infinite loop. Okay? So, okay, what it does is, okay, so I'm gonna write it here so that it is on record, being recorded. I did start the recorder, didn't I? No, I did not start the recorder. I thought I did. Oh, it's another terminal. Yes, I did. Okay. Just kidding. Yes, yes. Okay, so in general, what I want you guys to do here, is to mention that it depends on the accumulator, okay? So if the accumulator, okay, I'll just use ACC for the accumulator, has a value of 0, it uses the low portion of the next word as a branch destination. Because in that case, PC++ would have happened. If the accumulator is 0, then the PC++ would have happened, and then it would have loaded the word next to this instruction, and then use the low portion of that word loaded into the PC, and use that to continue execution. So that's one thing that will happen here. The second thing, is what if the accumulator is actually non-zero? If the ACC accumulator has a non-zero value, it branches to the location specified by the low portion of the TAC instruction. Okay. So not exactly these words, but I'm looking for all of these elements. Does it depend on the accumulator? Yes. Now, how does it depend on the accumulator? If the accumulator is 0, where am I going to? It's the low portion of the TAC instruction itself that will determine where you're going to. What if the accumulator is 0? Then it will be the low portion of the word that is following the TAC instruction. In this case, it's going to be, I think it's 004 in this case. No, it's 004, the one that's following. In other words, if location 8 has a value of 0, I would have loaded 0 into the accumulator. In that case, PC++ would have happened, and so I'm loading the word from location 002, and then I would have used 004 as my destination to branch to. In other words, it is doing something like this. Okay, the instruction is doing the equivalence of if ACC equals to 0, go to, in this particular case, it would go to 004, else go to 003. That's what it's supposed to do. That's the essence of what this particular instruction is doing. Yep.
So why is not an infinite loop?
Why is it not an infinite loop? Because in both locations, 003 and 004 has the fetch instruction. It doesn't do anything. But I'm asking you what this particular instruction does, not the entire program. So the
003 has like 000, it goes back to 000.
But if you look at the instruction on 003, it is basically corresponding to the fetch instruction. So it's fetching from, in this case, let's see. Oh, because it's going to fetch 003 again.
It goes back to 000.
It's going to go through this cycle, which goes back to here.
Yeah.
Oh, I see. But so you're describing what the entire program is doing, but instead what I'm asking for is just the instruction itself. Okay, so if you already describe the instruction itself also on top of describing what the entire program does, and I grade you incorrectly, you have to kind of send an email to me and say that, okay, I did mention what the instruction itself does on top of the entire program. So send me a note if that is the case. All right. So are there any other questions about this particular question? Okay. All right. Now, to test this one, you can actually put it into Johnny and actually test it. Okay, because it is, I did test this program before, or at least this instruction before I put it into the question. All right, so there goes one question, and here is the second one. Second one is Q2, and I'm going to look at the first revision of that. Okay, this is our favorite type of question, how the finding, right? The finding type, type of homework assignment. However, I did design this one to have plenty of partial credit.
You did us dirty on this one. You did us dirty on this one. Because you put it outside the range.
Outside the range, yeah, but most people recognize it's out of range, and it is only the last one that was out of range. So even if you don't recognize it's out of range and need to indicate it's out of range, the proportion of points in that one is that much. Okay. So let me kind of describe what you need to do to get full credit for this particular question. The first thing is to read the instructions. Okay, so the instructions clearly said you have to map out the values of bytes, okay, in italic, which means you have to give me the individual bytes, not as a chunk of 4 bytes or as chunks of 2 bytes. On lines before the definition of underscore start, you can assume all numbers are in base 16, so you don't have to specify 0x with all the numbers, because it would be very, very redundant in that case. Use a comma to separate the values of different bytes so it's easier for me to read. Okay, so I did specifically mention the format of what I'm expecting. Okay. All right, so let's do that first. Okay, so I'll do this line by line. Do it with this line first. With this line, it'll be 0x23, or just 23, 0, 0, 0, 0, 0, 0, because these 4 bytes together will spell out, well, I just did not follow my own rules, did I? Comma, exactly, comma separated. All right, so it's comma separation. Okay, so that together it means 23 in hexadecimal, because the other 3 zeros are leading zeros that are implicit in that particular word. And then the next one is going to be 70, 06, 0000. And then the last one is going to be A2, E4, 0000.
Yeah.
Okay, so that's the first line. And then the second line is underscore start. And because we don't really know the location of the start, so I'm okay with just, that. Okay? Or if you just, say question mark, comma, question mark, comma, question mark, comma, question mark, that's fine too. Because all I need to know is it will take up 4 bytes, and we don't really quite know the values of those 4 bytes. It's perfectly okay. Is that okay so far? Okay. Next line. The next line is the easiest one because they're just individual bytes. So you just have to specify those byte values in the same order, and that's perfectly okay. And then the last one, these are words, so you have to remember little endian also. So it's EB2F00001807. Your version of the test may not be exactly the same, but the approach is going to be exactly the same. Do we have any questions about this part of the exam? Okay, just spelling out what are the individual bytes of those definitions.
So you have a photocopy of the entire page, correct?
Yes.
I have my bits on the my page without being showed up on the photocopy.
That should, yeah.
Okay, I'll send you.
Yeah.
If you put commas in between, if you didn't put every single comma, is that class point? But you still have all the bytes in the right order.
Unless it becomes ambiguous, okay? If you put all the bytes together with no spaces in between, so I cannot even see the boundary between the bytes, then I would have taken points out. On the other hand, if it is clear, it's 2, 3, some distance 0, 0, some distance 0, 0, I probably would not have taken any points out. All right. So are there any questions about this part, the first part of the exam? Question. Okay. I think yep. Go ahead.
What if I write to 2 lines just?
That's fine. Yep. In fact, many people did it with 2 lines. In other words, they put all the byte definitions onto one single line, which makes perfect sense because you need to find out the displacements, from underscore start back to the individual bytes. So it's actually handier to string them all up onto one single line, or if it wraps around 2 lines. Yep. Many people did that. I just want to do it like this because it's right next to the definition of each line. All right. So once that is done, for the rest of the instructions, I also indicate what needs to happen. The first thing is indicate the value in the register affected by each instruction. And if the source operand is a memory operand, you want to specify the effective address of the memory operand. So you need to tell me where is it copying from memory. Okay, and that's when things start to get a little bit difficult for me because I want to give you guys partial credit, and different people gave me different answers for this part. Some people used the equation thing. Okay, some people gave me exactly this is underscore start minus 19. Which is what I want, okay? I want you guys to give me underscore start minus 19 because that's what you need in order to find out what is being copied. But I do give partial credit if someone just gives me the equation, okay? You just say, okay, the effective address is going to be underscore start minus 19 plus 2 times whatever EBX has. That will give you partial credit already, okay? So there are 4 stages to get points. The first one is 0 points, which means there's no answer or completely wrong. The first one is you give me the equation, but without actually telling me the value. The third stage is giving me underscore start minus something, minus 19 and whatever, and it is correct. But you did not tell me exactly what is in the register after the fact. And the fourth one is you give me everything that I need, including the effective address and also the content in the register after the instruction. Yep.
How many points does it do not have the correct number?
Okay, what number? Are you talking about the effective address?
Underscore start minus.
You will get 1 point. No, you will get 1 point out of 3 in that case. So you will get 1/3 of the point values in that case.
For the entire
For the
question.
For that portion of the question. So for each instruction, I apply the same grading mechanism. Okay? All right. Yep, go ahead.
So what is in the register if out of bound?
If it's out of bound, you just have to indicate it's out of bound or put question marks in place of the bytes.
What is in the register if you're out of bound?
As it turns out, it is 0. But those locations turn out to be initialized to zeros. But technically speaking, we should not know what it is. So you should use question marks to indicate, well, we don't know what it is, but I know it. I will be attempting to copy from that location. Some people even indicate that it will be a segmentation fault, which is fine. I took that as a correct answer as well.
Yeah, it's a
As long as they tell me which location the instruction is attempting to read from and it is out of bound, I will still give partner full credit for that. Yep.
What were the actual locations?
Well, that's what I'm going to do next. I will answer my own questions, okay, in full detail. All right. So the first 2 instructions are easy because the first operand is not a memory operand. Yes.
What % of the exam is each question worth?
They are all the same.
Oh.
They have equal values. So I just randomly, scale everything to 10 points for each question. But the entire exam, add up to 20% of your final grade. So there's a lot of scaling thing happening, but since I'm using Moodle, I let Moodle to handle all the scaling part of the grading part. All right. So in the first question or in the first instruction, all you have to do is to say EBX ends up with a value of -3. That's good. Okay? Not a problem. So with this one, there's really no partial credit because the first operand is not a memory operand. So there's nothing to describe about the effective address. So that's why this one is basically all or none. Okay, it's either telling me it's -3 or not. Now what I was kind of, yes, go ahead.
What if the person had $, -3? I just wanted to.
I don't even bother to take away points because of the dollar and what
Or percent.
or percent exactly.
It says EBX equals.
Yeah, if it seems right to me, it's okay. Okay, so the first one is EBX gets a value of -3. The second one is EBX or ECX gets a value of -1. There's no need to represent everything in hexadecimal. Some people did, okay? Some people gave me FFFFFFD for -3, and then FFFF for -1, which is perfectly okay. I took those answers as correct. But if you do it that way, you better make sure your base conversion is right. Because somebody, 2 people in fact, gave me the identical answer, wrong answers, of 0, 0, 0, 0, 1, 0, 1, 1, for one, and then 1, 1, 1, 1 for the other one, which are incorrect because those are base 2 numbers. We are dealing with either base 10 or base 16, and there should not be any leading zeros either. Okay, so there were 2 people who gave me somewhat awkward answers to represent -3 and -1. I could kind of see, as a 4-bit number, those would be the correct representations as base 2 numbers, but not when they are base 16 or base 10, which is the case in here. All right. I think I gave those people maybe partial credit. I cannot remember, but it was really awkward that 2 people made identical mistakes exactly the same way, and those were weird errors to begin with. All right. So this one is the first one that starts with partial credit because the first operand is a phased, scaled, indexed operand. Okay, it is a memory operand. So now we have to go through the whole procedure to give me exactly what the instruction is going to do. So I'm going to start with the equation. So if people give me the equation like EA, which is the effective address, being _start plus ECX plus EBX times 4, that alone is going to give you 1/3 of the point values for this particular instruction, which I think is pretty cool because it's just applying the equation. Even though if you don't have any idea what that ends up to be, you still get 1/3 of the credit for this one instruction.
What if rather than ECX and EBX you use -3 and -1?
You still get okay, it depends. If you substitute ECX and EBX with actual values, like -1 and -3 in this case, then I can figure out, okay, I can add. So that adds up to -13, right? So you will actually get the next step up in terms of points because it is equivalent to giving me underscore start -13. Right?
Like that was the final answer.
Yeah. So that would give you like 1 step up, which is 2/3 of the point values for this particular instruction. Yep. One plus 12? There's no L1 in the entire program. But there's no L1 in the program. I mean, so that really is not, Say again? Well, because there's no L1, I cannot refer to L1 and know what you're actually talking about.
Giving a location of where the underscore
So why don't you convert it to use underscore? You can start.
I don't know.
Well,
you don't use it.
and then it is not the question, it's not the answer.
I'm just wondering, is it like just give like a location to where I'm referring to?
But part of the question is to see whether you know how to use underscore start to get back to the content. Okay. Okay, so this will give you the first stage, of the points. This will give you the second stage of the points, which is basically doing all the math based on the values in the registers at that time, which is underscore start -13. Okay, so that gives you the second stage of the points. If you give me exactly what is going to be in ECX after the instruction, you get all the points. But you cannot just give me the content of ECX. You still have to give me the effective address to get all the points. A few people gave me just the content in ECX after the fact, so those people lose 1 point because of that, out of 3. Because in the instruction, I did ask for the effective address for every single instruction. Yep.
What if they have that, but not exactly in that location? I'll talk to you about it.
If the location is wrong, then it is considered wrong. So you would still be, if you give me the instruction, the equation, you would drop back to the partial credit just for the equation.
But we have ECX equals percent ECX equals underscore start -13.
That is actually incorrect because it is not getting underscore start minus 13. It is getting the content at that location. Okay, and that is actually one of the major confusion that causes problems down the line. Okay, so I'm going to describe it here next. What I'm expressing here, you can see that I'm using EA on this side, which means I'm only expressing the effective address, not the content that will go into ECX. Because if that is the effective address, if you do the calculation, EAX will end up to have the content of just underscore start, the label itself. Okay, there's no easy way for me to combine these two lines without getting it to be narrower. There we go. Okay, so this will give you the full credit for this particular question. Is EAX, the register, will get the value of the label underscore start. Sorry? What does underscore start minus 13 do? That is the address. That is the effective address. In other words, if you want to give me everything in pseudo C, this is what it would look like. Okay, so if you want to give me everything in pseudo C, it would look like EAX gets the content pointed to by underscore start minus 13, and that turns out to be the same as the label underscore start itself. So the most concise way to get all the points for this particular instruction is that. Which is what I did in class. The way I went through an example question related to this in class was to use that notation. Right? But if you give me something that basically follows that same line of reasoning, I still give you credit for that. It depends on whether it's confusing or not, whether it is correct, accurate, and complete. Okay. All right. So now that we know how to express this kind of stuff, let's look at the second line and try to deal with it. Okay. So once again, the first thing is to find out the effective address. So in this case, it is EAX again. Oh, the other one is ECX. Sorry. Okay. So this one is EAX. So the first thing you want to do is give me the effective address. The effective address in this case is -19 plus whatever ECX has at this point. Okay, so just giving me this will give you 1 point out of 3. Okay. The next stage is to figure out what exactly is ECX. Okay, so ECX at this point has a value of underscore start and not underscore start minus 13. Okay, quite a few people mistook the first instruction and say that ECX ends up with underscore start minus 13. No, it does not. Okay, it ends up with underscore start itself. Because it is a memory operand, we are not loading the effective address into the register, we are loading the content at the effective address into the register. So quite a few people made that mistake, but as long as you still show me the steps to get to that part, as long as you still show me this part here, you will still get partial credit for that. Okay, now that we know the effective address is underscore start minus 19, then you can go to that location and find out what is exactly at underscore start minus 19. And here, this is why it helps to really have one linear representation of all the bytes, because you can count backwards a lot easier that way. This is -1, -2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So we are basically copying these 4 bytes into the register EAX in this case. But remember, those bytes are specified by location, by memory location. So that means the one at the lowest memory location, the leftmost one, become the least significant byte when it is copied into EAX. And I think 1 or 2 people copy in the wrong order, forgetting little endian order. So in this case, it becomes E4 A2 0000. Okay. Are there any questions about the third last instruction? You know, what it is, what the answer is supposed to be, and why it is the answer. Okay. Now, because some people thought ECH will end up with underscore start minus 13, the effective address becomes underscore start minus 30, 31, 32 at this point. So with those here, I will take partial credit. I will give you partial credit if you give me the general equation to begin with. Because that shows me that you know what the instruction is supposed to do, but since you got the answer wrong in the previous instruction, you did not get the actual correct effective address.
Yep. So even if you came up with the minus 32, if you didn't write the actual equation, you don't get points?
That is correct, because I would have no idea how you came up with that number. Huh? Okay, there are 3 steps, okay? This gives you 1/3 of the points. If you can get to this part, it gives you 2/3 of the points. And if you can get to this part and also the last part, that will give you all the points for this particular question. So what I have highlighted now at this point, if you just give me that, that will give you the full credit. Yep.
I can still understand why you get rid of minus 13.
Why is it not minus 13?
Yeah,
Because I'm loading, okay, the first instruction, okay, this is getting back to the instruction before this one. The effective address is not underscore start minus 13. That part we know, right? Because we do the calculations. But if you look at, underscore start minus 13, that is not what we are putting into EAX or ECX, because that specifies the address from which we are going to copy 4 bytes into the register. So when you actually go to that location, this is -1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we are basically copying these 4 bytes into ECX. And these 4 bytes is underscore start. And that's why ECX ends up with the value of underscore start, the label itself. Okay? All right. So this one, gives you, basically the same opportunity to get at least partial credit, because if you want to express this whole thing, now this is AH. Yep, go ahead.
When you started counting to figure out what was going in the EAX, you used ECX. You started from 07 byte, but I thought ECX's effective address was underscore start, which was a label int underscore start. So how come you don't start at the question marks? You start at the very end of the bytes.
Because the question marks represent bytes that are representing the value of underscore start as a label. The definition of underscore start is right after the dot word directly.
So, but I thought ECX was now equal to underscore start. And so on that line, you don't start with the underscore start bytes. You would start with underscore start at the end of the bytes.
The label. Because underscore start itself is just a value, and that value turns out to be an address. And that address is right after the last of the dot word directory, the definitions. Okay. So if you draw out the picture, we have 2, 3, 0, 0, 0, 0, 0, 0, and then we have 7, 0, 0, 6, 0, 0, 0, 0. We have 8, 2, E4, 0, 0, 0, 0. And then we have 4 question marks because they correspond to the value of underscore start itself. Okay? And underscore start itself is an address. Okay, that's the beginning point of the entire program. And then after that we have 4, 5, 5, 7, B4, and then we have E2F 0, 0, 0, 0, 1, 8, 0, 7. This is where underscore start is. Underscore start is a memory location. Okay, and that memory location is right here. So this location becomes underscore start -1, underscore start -2, and so on. This location here is underscore start -13, and this location is underscore start -9. Is that help you?
Just having your int called underscore start kind of threw me off, I guess.
Well, that's part of the homework assignment. Remember, we have one homework assignment where we have .int L1 or L2. So it has the same nature as this homework here. And it has this question. One thing you can do to make sure that you really understand the concept is to actually just type it in. Now that you have your exam spec, type it in and run the program through GDB. And as it is running through GDB, examine the registers. So that way you can actually clearly see how the values of these things are loaded into the registers. And also to make sure that I didn't lie. That's important. Or, otherwise there's only something that is not true unintentional. But it is important to go through GDB because in GDB you can see all of these steps somewhat more clearly. All right, but just to finish this, okay, so in this case, AH is the only one that is affected. The effective address is no longer that of a 33 integer, but a char. So the equation is -19 plus ECX, the value in ECX at the time, plus 2 times EBX. Okay, so if you get all the values calculated correctly from before, then you'll be able to find out that, oh, okay, so this is actually the effective address of underscore start minus what? We have ECX being underscore start. Okay, let me check. Underscore start is in ECX, and we have -19 here, and EBX is -3. So 2 times -3 is -2, -6. So combining everything, we have the underscore start minus 25. So if you look at this picture here, we have -19, 20, 21, 22, 23, 24, 25. So this one is at the underscore start minus 25. I'm not prefixing everything with underscore start something because otherwise it will take a lot of time to use this right now. So it'll be the 2-3 byte that is loaded. So that will give you, the full credit for this particular instruction is to give me the 2-3 going into AH and also the effective address of that particular byte. Where are you copying from in order to get that 2-3 byte? But if you give me the general equation, you will still get partial credit, even if it does not add up correctly. Is that okay? Yeah. All right. So the last one is kind of tricky because it looks almost the same as this one, except the range is out of range. So in this case, it is out of range because AL is going to get the byte at the effective address of 4 times EBX and not 2 times EBX. So when you look at the values, it becomes -31, and that is out of the range. We did not, we don't know, what is the content at that location. So you can just use, question mark to indicate we have no idea what it is, and then you have to put that question mark into EAX because I want to know the final content in EAX. So you kind of still have to find out which part of EAX is going to get those 2 question marks. Yep.
So each of these instructions have equals.
Yes. When you look at your score as an assignment, it is rubric based. It's a list about this long, and you can see how I assign the point values. So I encourage that you take a look at that, find out how. For question number 2, did you look at the rubric?
I looked at the rubric as well as the feedback section.
There's no feedback because the rubric is the feedback. That gives you far more information than I can just type and say, okay, this instruction is wrong, because that tells you exactly how much requirement is met for each point value, and that's why you get that many points. Okay, are there any questions? Coming up with the rubric itself is a long process because I have to break everything down into little chunks and then have put partial credit into the whole thing. Yep.
So the entire exam is out of 45 points?
The entire exam, okay. each homework, okay, each question, according to Moodle, is going to be a 10-point thing. So you can add up to what, 30 points, right? But the 30 points will scale to 20% of your final grade. So when you look up, x1, as an aggregate, it will be scaled to 0 to 20. But when you look at each individual question, it will go from 0 to 10.
So how would we figure out like an overall?
You look at x1. So if you look at x1 as a category, that will give you the percentage of this particular exam. It's 20% of your final grade. Okay, so if you get 10 out of 20, that's a C. If you get 15 out of 20, that would be a B. If you get 5 out of 20, that would be a D. And 0 out of 20, obviously, is going to be an F. Is that okay? So as a final result here, the final result here for this particular question, yours may be slightly different. Will be E4, A2, and then 2, 3, oops, yep, and then question mark, question mark. The other variant only has the constants being slightly different, but otherwise it's the same same reasoning, same addresses, and so on. Are there any questions? Any questions? It's kind of like Find It, except this is the reverse of Find It. With all the Find It homework assignments, I give you the final pattern of what needs to end up in a particular register, and then you have to do some detective work to find out, okay, how do I grab things from memory locations to get to the final product. This one is kind of the reverse, which means I give you the content of everything, I give you all the instructions. You only have to follow the instructions to find out, okay, what is going to end up in EAX because of the instructions. So in a way, it is easier, but in a way, it's different. Okay, it's different from the homework assignments, but closely related. All right. So are there any questions about the question itself, the answers, and also how it is scored? How many people have actually read the rubric of these questions? Okay, quite a few. It took me a little bit of time to set up the rubric. But once it's set up, it's easier to grade because I can just go through all the items and go, okay, does it meet this requirement? Yes. Does it meet this requirement? No, and so on. It took me about an hour, a little more than an hour for each question, and then another 20 to 30 minutes just to set up the rubric. Next time, I'm going to set up something that's easier for myself.
Multiple choice. Multiple choice.
Or none. Does the program work? If it doesn't work, then it doesn't work. I used to do that with this class, because I was able to use the computer lab. So I would actually give practical questions. In other words, write a program to blah, 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 blah. Okay? And then the idea was I would grade it by test cases. Okay, so if you can implement only a part of the program, it only works for certain test cases, you'll still get partial credit. But what ended up, as a result, was very few people could even get the program to assemble correctly at the end of the process. So it turned out to be not really such a good way to do assessment. To basically say, write a program to do something, and I will give you credit based on the number of test cases that it works on. Not a very good idea. But I thought it would be a good idea because that's what you need to do at work too. Your boss is not going to give you partial credit or partial salary when your program is working sometimes or not compiling, but it's mostly done. Can we deliver the product tomorrow? Yes, we can deliver the product tomorrow, but immediately after that we have to send out like Surface Packs, right?
Really, then what's Windows Vista? Really, then what's Windows Vista?
And Windows 98.
Yes.
Yeah. Yeah. Microsoft tends to do this type of thing, over and over again. Yeah.
Now learn from my mistakes.
All right. Last one. The last question. The last one is Q3, and there are two variants of this one as well. So you can kind of imagine how much time I have to spend on just making the questions, right? Okay. So this is the question, and I was surprised by the outcome of this question because I would say at least 50% of the class got it completely correct. Everything is right. Okay, and I was surprised because I never really presented this kind of question in class. I presented the material, I showed you the gates, I showed you, how everything works, the equations and whatnot, but I never really gave you questions like this. And people did not have a single problem with this one. Whereas in question 2, I was thinking question 2 should be easy as easy sneezy because we had homework assignments. We have 2 homework assignments with that sort of thing. And all of the constructs, were basically rehashes of things that we have already done with the homework assignments. So in my mind, I was thinking question number 2 should be like most people should get 100% or close to 100%. Not quite so. Okay, and I was thinking this one would be disastrous because I have never asked questions like this before, and it was the opposite.
This one is disastrous. Why you gave us one? When you knew it was going to be disastrous, why you gave us something like that?
Because I need to do assessment to see if you guys understand the concepts or not.
The disastrous question?
Well, I thought it would be more disastrous, but it should not be beyond the reach of a student in this class. And it turned out to be pretty good. Most people did this really, 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 really well. Okay, so I'll just kind of go over this one really quickly. Okay, the incoming carry is 0 for this column, and then both inputs are 1s. 1 plus 1 is a 0 with a carry, so that automatically turns this carry to be a 1. But then 0 plus 0 is a 0, so the output, the result bit of this one is a 0. So this is a 0, carry out is a 1. So now we have 1 as a carry in, we have 1 as the input, and we have 1 as the other input. So that means the result is going to be a 1, and so is C out. Are there any questions about this one? Okay. The next one is a little bit trickier, okay, but not too tricky. Carry in is a 0 because this is the least significant bit. We have 1 incoming bit to be a 0, but I want the result to be a 1. What is the only thing that can make that happen? A 1. The other input has to be a 1. But the carry out is automatically a 0, and I put a 0 here already, so you don't have to answer that one. Okay, so incoming carry is a 0. 1 input is a 1, and I want the output itself to be a 1. So what do you think A has to be? 0. Can only be a 0. Okay, so that's it. And then the last one is carry in is a 0, output is a 0, and the carry out also has to be a 0. What do you think the inputs have to be?
0, 0.
They both have to be zeros. Exactly. So knowing the carry out is a 0 from the first adder and the carry in is the same thing, is a 0, I want the carry out to be a 1 in this case. What do you think this has to be? 1. Has to be a 1 because otherwise we cannot make the carry out to be a 1. And since this is a 1, this is a 0, this is another 1. 1 plus 1 is a 0. So so R itself is going to be a 0 for this particular question. Right? So that's it. But with this one, each bit is 1 point. Okay, so it's scaled, evenly. There are 9 bits that you have to specify, and there are 10 points to this question. So it's just evenly scaled, evenly distributed. So each one is worth what? 1.1 points or something like that. So are there any questions about the exam at this point?
I'll go ahead after that.
Okay. Okay, any questions? No? What about the current homework assignment? Someone turned in an answer already. That's pretty good. The current homework assignment, the one that you have to read a byte and then determine where to send it to. Any questions about that? Has anyone tried to do it? Okay. Yeah, go ahead.
Can you move back the date to Thursday, please?
No, you can't do it. You can't do it. You have to structure the program right to get this one done because the logic seems to be complicated, but it's not too complicated. Okay. What is the main difficulty of this particular one? Go ahead.
I think we should vote result.
Say again?
Result label. Result.
Else?
Result.
The result variable?
Yeah, because our cycle depends on the result.
Yeah.
And read supposed to pass something to result, but our
Okay, let's let's take a look at the homework assignment first, so this way we have a reference point. So I'm going to close this, and close that. All right, so we are now in file IO. All right, so here we have the pseudo C code. Yep.
On size.
Oh,
Yeah.
font size, bump it up. There you go.
I mean, read should pass something to resolve, but system call read doesn't have anything like that.
Yeah, it does.
Where?
All right, so let's go back to my notes. We actually talked about this last time too, in class. Okay, but we'll take a look at the notes also. All right, OS call in assembly. That's where we're reading from a file.
Yes.
Can you use EAX for
The result.
yes?
Okay, so I'm just going to look for EAX here. Right here.
Mm-hmm. Yeah, thank you.
Yep. Okay, any other questions about the homework assignment?
We have some questions after turning in. Remember, can you do the assignment?
You want to take a look at the homework
Yeah.
assignment? Okay. Let's see, the homework assignment is right here.
Yeah, the last, and below, you have like, test in. What are you gonna do with test STD out?
Okay, this one I
So
demonstrated
C
in the previous class as well. Actually, in this case, you will need a 3 greater than as well because we are using the 3 file descriptors. Yep. So you will need to specify, greater than, or implicitly is a 1 greater than, and then you have 2 greater than, which means we're capturing the output from file descriptor 2 to, in this case, test.stderr, standard error. But you will also need a 3rd one because we're using 3 file descriptors. So let me change the description of the homework to match that. But I did go over an example last time of how to test your program and how to check whether it's working correctly or not. So let me just I will just go ahead and okay, because you will have 3 outputs in this case. Okay. No?
Should there be a 1 in front of that?
You can have a 1 or you don't need a 1 because if you use just the greater than symbol, the 1 is implicit. So when you're redirecting, you're implicitly redirecting standard out unless you want to redirect something else, then you have to specify 2, 3 in this case. Yeah. Any other questions about this particular homework assignment? Yep.
So when you're using, are we gonna need to implement compares then to move it to the correct spot, like a CMP?
Oh, you would need a lot of compares
Okay.
in this case. Yeah, you need a lot of compares. Let me save this first, so that I don't forget to save it later on. Okay, you will need quite a few compares because every time you have something like this, that's a compare. When you have something like this, that's a compare.
Right.
So you do need quite a few compares if you want to implement it correctly.
Right.
Yeah.
Those little quotes say that that's a
ASCII code. Yeah. The single quote step, you can use the same thing in assembly. So you can say CMP blah blah blah, and the immediate operand can use single quotes as well. So there's no need for you to go to the ASCII table to find out what the ASCII code is.
you could do, so you effectively could do CMPL instead of comparing two registers, you could compare like EAX to like -1 or something like that.
Yeah. Now, you have to be careful about which one is -1 and what type of negative are we talking about, because -1 without a dollar sign is a direct memory operand, which means you're going to memory location FFFF to load its content. With a dollar sign, then you're actually comparing to the value of -1 itself. Okay? Now, let me give you another warning. With this one, you really want to specify the width of operations for every single instruction. Okay? Because you can see that CH is a byte, it is not a long. Okay? If you use a long compare in place of a byte compare, your program may appear to work for certain cases, and then it may not work for other cases. Okay, yep, go ahead.
I was just wondering, what's the UN32 and UN8 at the top?
That's just 32-bit unsigned and 8-bit unsigned.
Okay.
Yep. So once again, uint32 is just my C way of saying, okay, it's a 32-bit integer, and you can treat it as an unsigned integer.
Gotcha.
And then uint8 is signed. In this case, it really doesn't matter because none of the ASCII values that we're comparing to is going to cross that boundary.
Right.
So I shouldn't say that because then people will say, oh, that means I can use JL and JB. Doesn't matter which one I can like not care about. Yep.
What's the pseudo C you got going on? What's the equivalent of the read function? What's it doing?
Yes, system surface number 3. System surface number 3 is the read operation. System surface number 4 is the write operation. Okay. I did this, in the previous class. Remember in the previous class I gave myself, an example to do. So I was actually translating the read call into assembly language, and I was also translating the write call into assembly as well. I can replay the video from last class. We don't compare already because the comparison stuff we have done already in the previous homework assignment. Yeah. So the only thing that is added here is how to read and how to write. So what you need to do is to kind of let me go back onto the notes from Tuesday just to remember what we went through on Tuesday. Yep, go ahead.
Can I have my test back?
Yes, let's do that after the class. Okay, at the end of the class. All right. So I'm going to do something that other professors cannot do. Okay, not easily. Oh, okay. What is that? I got hacked. Again. Open the tab. That's interesting. No, well, remember, I'm running this out of a live distribution too, and this is without persistence. So it's not anything that I have done to the installation too. Let's go to YouTube, and that works out okay. What?
So you've been watching Simon's Cat.
Okay, let's go to videos.
Yeah, that's not bad.
That will make a pretty, easy class to teach today. Okay, full screen mode, and we'll go for HD. It is in HD already. Okay. All right. And we'll slide it. All right. So with the first part of the class, on Tuesday, I implemented this program in C, and I illustrated how you should test the program. Okay, using the redirect operation and using GDB also. Okay, in GDB you can also use redirection with this particular program. So that's the first part of the class. In the second part of the class, and let me see where it is.
Screen put on the transcript. Transcript.
Transcript?
Yeah, that
Oh, you mean closed captioning? Yeah, that would work. Okay, so right here, this is the illustration of how to do a read operation. This is the same thing as reading from file descriptor 3, excuse me, this is the same as reading from file descriptor 0 into buffer 20 bytes. And whatever EAX comes back with is the result, is the return value.
So what is that reading from? That's reading
It's
from?
reading from standard in. It's reading from file descriptor 0. So this is the same thing as what you see on the whiteboard right now, I mean on the projector right now, is the same thing as read, and then the first parameter is the file descriptor. 0 means standard in. Where we are putting all that stuff, in this case, is the location of buffer, but to do this in C, you have to use an ampersand to mean the address of. And then the last one means, how many bytes am I reading? In this case, I'm reading 20 bytes. Okay. The return value is stored in EAX. So if you want to look at it from the C perspective, it is the same thing as EAX gets the result of the read operation. Is that helpful?
Are the graded phase
So
on
it's
the
just a
EX?
simple read.
I just wrote like 5 lines of your program.
So changing it to a write operation, you would change the $3.
Exactly. Changing it to a write operation means you have to read. Oh, I just clicked on this one here as if it is my browser window, but it's not. I almost got myself. Yeah. I almost got myself with that one.
Yeah, and
Okay.
now it will be on YouTube forever.
Yes, my blunders. Someone can compile all the blunders. It's like look at how. Yeah, exactly. And sell it on eBay for money.
Yes.
So this is the write operation, and it describes how you do the write operation. With the write operation, EAX has a value of 4 to mean system surface number 4. That's it. That's the only change. No. I already answered that question a little bit earlier. Okay. You have all the pieces. You already have all the pieces since Tuesday. Okay. So the question is, how do you put all the pieces together? That really is the question. Yep.
How big do you want the buffer to be?
Well, let's take a look at the program to find out how big of a buffer you actually need in our homework assignment. All right. So let's go to this text here. Okay, so the question is, how many bytes am I reading with this statement? Well, there you go. That's your answer. Because we are also when we are writing, how many bytes am I writing at a time?
1.
Yep, that's it. So you only need 1 byte as your actual quote-unquote buffer.
So we only need to test out one.
Exactly, we're doing processing byte by byte. And believe it or not, from the logic perspective, it's easier to do it this way than to process multiple bytes at the same time. Because if you want to process multiple bytes at the same time, then you have to figure out how many bytes did I actually read back, and then process all those bytes one by one, compared to the boundary, compared to the length that you actually read, until you run out, and then you try to do another read operation. This is a whole lot easier. It's not efficient because you're reading only 1 byte at a time, but it is a whole lot easier to code because you don't have to worry too much about, oh, did I run out of space on the buffer? How many bytes is actually in the buffer for me to process? There's only always 1 byte. Okay. Well, okay, I take it back because it can be 1 byte or 0. When you're reading back, when result is 0, it has a special meaning. What does it mean when result is 0?
End of file.
End of file. That's right. When you encounter end of file, what should you do? Yep, that's it. You should quit. Only when you encounter 0, not to quit this class, to quit the loop. Okay?
I don't remember seeing a lot of format restrictions on the homework, but you said you were going to be running a script to make sure our code runs right.
That is correct.
So
This
are
one
you
has
giving
no.
us-
Okay, what I'm going to do is I will run the C code first to create, okay, first of all, I will create a test case. To create a test case, you just have to look at the code here and say, okay, what kind of test case can be created here? 0 to 9 seems to be one range that is important. A to F in lowercase is one range that is important. Uppercase A to Z seems to be important. Lowercase a to z seems to be important. And everything else seems to be important too. Now, everything else being the line key character, the space, the punctuation, stuff like that. So as long as you have all groups of characters that I mentioned here in your test file, what you can do is to write the C version of this code first, generate the correct outputs, then you can basically use that to test your assembly version of the same item. So my program, my script is going to do exactly the same thing. I will have a test case, as the input that I will feed into your program, and then whatever program or whatever content your program outputs to file descriptor 1, 2, and 3, I will capture those and save those into files, and then I'll just be comparing the files output by your program against the key, which is the output of my C implementation of the same program.
Are you going to let us look at your script to see what you'll be testing?
Well, we did one on Tuesday. There's really not a whole lot of variations.
No, I know. Just wondering if we'd be able to see your script just so we can look at it and see the format of it.
It's just regular stupid sentences like this is a test.
Oh, okay.
Yeah. This is a test, and make it multi-lines just so that I know you capture the line key character and stuff like that. Which it should. If you can capture, if you can process a space and the period and punctuations correctly, line feed should be captured and processed correctly also. So I can give you one test input file. Okay. Okay. The other thing you should be able to do. Okay. There are several things you can do to really get this project working. Okay. First of all, look at this code here and turn it into an actual C program, which I did last time. Okay, so if you want to save yourself some time, replay the video from Tuesday, freeze the frame, and then just copy it into an actual program. Do not ask me where's the source code, can I upload it to Moodle, because I cannot. Okay, it's gone. Okay, I did it in the temp folder, it's gone already. Okay, but it's not that long. Okay, just type it. So type it in as a C program. Give it a test file, and last time I gave you a test file already. The test file that I generated last time was a good one. Okay, that one is just as good as any other test file. So use that one. I kind of showed you the. Go back to the video. Okay, so I showed you the correct output already, which is right here. Okay, so that's the correct output of that particular program. To output string or output file descriptor 1, we should have 1, 2, 3, lowercase ABC, ABC. To file descriptor 2, we have uppercase ABC, lowercase XYZ. And then to file descriptor 3, we have, I think, 2 line key characters followed by exclamation point, the @ symbol, pound symbol, dollar symbol, and then another line key character. So that's already telling you what the program is supposed to output based on the input. The input is earlier in the video file. Okay, so if you scroll back a little bit, you can actually see the input file. I also mentioned the use of diff as a tool to compare two files. So you can use that to basically compare what is expected out of the program as opposed to what is the actual output from your own program. So any other questions about this? It is a little bit more tedious than find max3 because of all the different comparisons. But if you do it in a more systematic way, it's not much different from what you had to do in the previous homework assignment. It's just a little bit more. And I already pointed out all the pitfalls of this particular homework assignment. Make sure that when you are moving or comparing, choose the right width. Okay, because you have control over that. You can do a B, a word, or long. So you got to think about that before you say, okay, I think I'm just going to use compare, CMP. Do not use just CMP, okay? Because there will be chances where you'll be comparing a constant, like a $, an immediate operand, to a memory location. Now, if you're comparing the media operand to a memory operand, no one is going to suggest the correct width of the operation, because the only thing that that has an inherent width are registers. So if you do not have register operands in an instruction, then it is up to the assembler to say, well, let me see here. I think a long could be a good default here, but that may not be what you want. Okay? So you got to think about the width of the comparison and the move operations in this particular program. All right? So all I can say now is get started. Okay? This is not any more difficult than the previous homework assignment, but you have to get started already. Okay.